Your review is just on 4.1. We're going to be evaluating functions using a calculator, graphing, stating whether or not there's a growth or a decay, and then using those interest formulas to find totals. So the first section in your review tells you to use the calculator to evaluate the function at the indicated values of x. The first one that we have is f of x is equal to negative 4 to the power of 2x. We're given values of 5, negative 2/3, and negative 6 for those x values. So if we start off with f of 5, that means that we're just going to do negative 4 to the power of 2 times 5. So again, you can use your calculator if you'd like to. That would give you negative 1,048,576. For B, you have f of negative 2/3, so that's going to be negative 4 to the power of 2 times negative 2/3. So again, just use your calculator. 2 times negative 2/3. You should get, but these are going to round to 3 decimal places if you have a decimal, so that's negative 0.157. And then for C, you have f of negative 6, so that's going to give you negative 4 to the power of 2 times negative 6. Which would give you negative 0.000, because again, we're just rounding to the 3rd decimal place. For number 2, we have f of x is equal to 5/8 to the power of negative 5x. We're given x values of 9, negative 3/2, and negative 2. So for the first one, we're going to have 5/8 to the power of negative 5 times 9. So 5/8. This gives you a huge number. So you have this as your answer. So with these, you won't round, obviously, but the ones with your decimals, you will. For B, you have f of negative 3/2. So that's going to be 5/8 to the power of negative 5 times negative 3/8. So in your calculator, 5/8 to the power of negative 5 times negative 3/2, not negative 3/8, 3/2. And that would give you 0.029, run to the 3rd decimal place. For C, you have f of negative 2, so that's 5/8 to the power of negative 5 times negative 2. And that gives you 9,536.743. For your next 2, you're dealing with the E, or your in your calculator, it's going to be that second or that shift button and then that ln button. So for number 3, you have f of x is equal to 4 times e to the power of x. We're given values for x of negative 2, 9/7, and 5. So we're going to start with the negative 2. That's going to give us 4 times e to the power of negative 2, which is rounded to the 3 decimal places, 0.541. For B, you have f of 9/7. So that's going to be 4 times e to the power of 9/7. Which is 14.469. And then f of 5 means that that's going to be 4 times e to the power of 5, which is 593.653. For 4, you have f of x is equal to negative 3/5 times e to the power of negative 6x. For a, we're given f of 0, so that's going to be negative 3/5 times e to the power of negative 6 times 0. So plugging that into our calculator, and that gives us negative 3/5 because e to the power of 0 is just 1, so that's just the negative 3/5. You can leave it as a decimal, or you can leave it as a fraction, or you can give it to me as a decimal, which would be just negative 0.6. For b, we have f of 2, so that's going to be negative 3/5 times e to the power of negative 6 times 2. Which would give you negative 0.00003687. Again, if we're rounding to 3 decimal places, that's just negative 0.1230. Then you have f of 2/3 for c, so it's going to give us negative 3/5 times e to the power of negative 6 times 2/3. So again, plugging that into your calculator. And rounded to the 3rd decimal place, that gives you negative 0.011. The next part within your review goes over growth and decay. And you're given functions and told to state whether or not there's a growth or a decay. With these, you're going to look at the number that has the power of x attached to it. That number, if it's greater than 1, has a growth. If it's less than 1 but greater than 0, it has a decay. So for number 5, you have f of x is equal to 3 times 9 to the power of x. That 9 is the term that x as the power is attached to. 9 is greater than 1, so we have a growth on this one. For 6, you have f of x is equal to negative 2/5 times 5 to the power of x. The 5 is the number that the power of x is attached to. It's greater than 1. So 5 is greater than 1. So we have a growth on this one as well. For number 7, you're given f of x is equal to negative 5 times 2/3 to the power of x. That 2/3 is the term or the number that your power is attached to. 2/3 is less than 1 but greater than 0. So this one has a decay. And then for 8, you have f of x is equal to 4 times 0.89 to the power of 3x. That 0.89 is the term that the power of x is attached to. 0.89 is less than 1 but greater than 0. So we have a decay on this one. Your next part goes over completing the function table and graphing the exponential function. You're rounding your values to 1 decimal place with these. For this function table, it does not give you values for x. However, on your quiz, you will be given values for x. Okay, so for this one, we're going to use values of negative 2, negative 1, 0, 1, and 2. For the negative 2, that's going to give us negative 2 to the power of negative 2. If we use our calculator, even though you shouldn't need to, you would get negative 1/4. So you would have negative 0.25 or negative 0.3 if you're rounding to the 1st decimal place. Next, you have negative 1, so that's negative 2 to the power of negative 1. This gives us, again, take the reciprocal of it, negative 1/2 or negative 0.5. Then you have negative 2 to the power of 0. Anything to the power of 0 is 1, so that's a negative 1 times 1, so that's negative 1. Then you have negative 2 to the 1st power, which is negative 2, and then negative 2 to the 2nd power. So negative 1 times 2 squared is negative 1 times 4, which is negative 4. If we go to graph these, the first ordered pair that we have here is the negative 2 comma negative 0.25, which is going to give you this point here. Then we have -1, comma, -0.5. So that's here. Then 0, -1. So that's here. 1, -2 is here. And then 2, -4 is this point here. So we would draw our line through these points. We're going to get really close to that x-axis, but we're not going to cross over it. Your next part goes over these interest questions. So you are going to be using your different formulas for these. You have to pay attention to how it's compounded. So if it's compounded continuously, you're going to use that a is equal to p times e to the power of r times t. If it's compounded annually, semi-annually, monthly, weekly, daily, any of those, it's going to be a is equal to p times 1 plus r over n to the power of n times t. Remember, your rate, turn it into a decimal. N is the annual, semi-annual would be 2. Monthly would be 12. Weekly would be 52. Daily would be 365. Quarterly would be 4. Okay. So for number 10, it tells you that a total of $5,000 is invested into an account with an annual interest rate of 3.4% compounded semi-annually. Find the balance in the account after 12 years, or after 2 years, sorry. This says compounded semi-annually, which means you're going to use the formula A is equal to P times 1 plus R over N to the power of N times T. Your A is the 5,000. Your rate is the 3.4 as a decimal. So 3.4% is equal to 0.034. N happens semi-annually, so that's 2 times a year, so N is 2. And your time, T, is 2 years. So we're going to plug all of this in. We're going to have A is equal to 5,000 times 1 plus our rate as a decimal, so 0.034 over N, which is 2, to the power of 2 times our years, which is 2. We use our calculator for this. 1 plus 0.034 over 2 to the power of 4. And that gives us $5,348.77. Remember, with these, you need to round to 2 decimal places because you're dealing with money. For number 11, you have a total of $3,500 that's invested into an account with an annual interest rate of 21.2% compounded weekly. This is compounded weekly, which means we're going to use the same formula as the one before this. Find the balance in the account after 5 years. So this means that you're using A is equal to P times 1 plus R over N to the power of N times T. Your P is the 3,500. Your rate is the 21.2%, which is 0.212 as a decimal. Your N, because it happens weekly, there's 52 weeks in a year. N is 52. And then your time is 5 years. So this all plugged in is going to give you A is equal to 3,500 times 1 plus 0.212 over 52 to the power of 52 times 5. We plug this into our calculator. We round to 2 decimal places, and this should give you $10,080.55. For number 12, you have a total of $3,575 that's invested into an account that earns 8% interest compounded continuously. Compounded continuously, that's important. Find the amount in the account after 3 years. So compounded continuously means that you're going to use that A is equal to P times E to the power of R times T. Your principal, the amount that you invest, is $3,575. The rate is 8%, which means that's 0.08. And then your time is 3 years. If we plug these values in, we're going to have A is equal to 3,575 times E to the power of 0.08 times 3. Again, we're going to use our calculator, round to 2 decimal places. And this should give you $4,544.72. For our last question, number 13, it tells you that a total of $600 is invested into an account that earns 3.75% interest compounded continuously. Find the balance in the account after 11 years. So your formula that you're using here is A is equal to P times E to the power of R times T. Your principal is the $600. Your rate is the 3.75%, which as a decimal is 0.0375. And then your time is 11. So if we plug these values in, you're going to have A is equal to 600 times E to the power of 0.0375 times 11. Plug this into your calculator, round to 2 decimal places. You get that A is equal to $906.35.